Today we're going to talk about families of functions. A family of functions is a group of functions that have common characteristics. So for example, linear functions can be called a family of functions, where the parent function of this linear function is the line y equals x, whose slope is 1, and the y-intercept is at the origin. So when we change the slope and we change the y-intercept, the steepness changes of the graph, and the graph moves up or down along the axis. This also is going to change the x-intercept. So the line y equals 2x plus 4 is a member of this family of functions, where the graph has been moved up 4 units, and the steepness, we say, is stretched by a factor of 2. So the parent function is the simplest form in a set of functions that form a family. And each function in the family is a transformation of the parent function. So we're going to look at y equals x squared, or f of x is equal to x squared. This is the parent function of our quadratic family of functions. We're going to look at how we translate this graph up and down, left and right, how we reflect it over either the x-axis or the y-axis, and how we stretch or compress this graph. So let's do a little highlighting. If the parent function is f, then f of x plus k or f of x minus k is a translation up or down. And if the parent function is f, then f of x plus h or f of x minus h is a horizontal translation, left or right. And then if the f is my parent function again, then we could have both a horizontal translation and a vertical translation in the same graph. So a vertical translation would be something like f of x equals x squared plus 2. So notice the plus 2 is at the end of the function. Also, we could have f of x is equal to x squared minus 3. Notice the minus 3 is at the end of the function. Okay, so if we look at a horizontal translation would look something like this. F of x is equal to x minus 3 squared. Notice the minus 3 is in the parentheses with the x. That's our indication that it's a horizontal translation. So this would be a horizontal translation to the right 3 units. With horizontal translations, it's always opposite of what we think it is. If the x minus something is going to shift it to the right, and x plus something will shift it to the left. We'll look at some graphs in just a bit. And then we can also have both a horizontal and a vertical translation in the same graph. So I could have an x plus 1 squared, which would shift our graph to the left, 1, and I could have a minus 2 at the end, which would shift our graph down 2. I wrote 3, I meant to write 1. Left 1, and then down 2. Okay, so we could also have a reflection of our graph. So if we could reflect it 2 ways, if we decide to reflect our graph over the y-axis, then our new function would be f of negative x instead of f of x. And if we decide to reflect our graph over the x-axis, then the opposite of f of x is what we would get. So if we multiply a function by negative 1, then we reflect our graph over the x-axis. So if x squared looks like this, then negative f of x would look like this. And if we want to reflect f of x over the y-axis, f of negative x would look exactly the same. We're just reflecting it over the y-axis. Okay, and we can also talk about a compression or a stretch. So if we multiply our function by a number that's bigger than 1, then we have what's called a vertical stretch. And if we multiply our function by a number that's in between 0 and 1, then we have what's called a vertical compression. So for example, we can look at these graphs right here. These graphs have vertically stretched by values bigger than 1. So we start with the black graph, y equals x squared. The red is 2x squared, the blue is 4x squared, and the purple, the real skinny tall one, is 15x squared. So if we multiply a function by a number bigger than 1, it stretches the graph and makes it more narrow. And if we multiply a function by a number that's in between 0 and 1, it's going to do the opposite effect. It's going to become flatter, or something like that. Okay, we can also look at these graphs here. These graphs have been translated up or down. Notice the plus or minus is at the end of the function. You can also look at these. These are our horizontal translations. Notice the x plus or minus is with the x inside the parentheses. That tells me that there is a horizontal translation. And remember, an x minus 2 would shift our graph. This is the x minus 2 squared. And an x plus 3 would be over here, x plus 3 would shift our graph to the left, 3. Okay, so we can, I'm going to change this problem. I'm going to make f of x squared, like what we've been working with. If f of x is equal to x squared, then j of x will be f of x plus 3. So that means that j of x is x squared plus 3. So if I go to my calculator, see if I can get my calculator open. I go to my calculator and I put in x squared. I'm pretty sure I know what that looks like. Let me clear all this business. Okay, so we've got x squared. I'm pretty sure I know what that looks like. And then if I go down to y2 and I put in x squared plus 3, then I see that it moves my graph up 3. So I'm going to say up 3 units. Okay, and then h of x is f of x plus 3. So h of x is going to be x plus 3 squared. And I think I know from what we've just talked about that this graph will be moved to the left 3, but let's check. So I'm going to go down to y2 and I'm going to clear it again. I'm going to put in x plus 3 squared. And I do see a shift to the left 3 units. So just verifying that this transformation would be to the left 3 units. And then k of x is equal to 4 times f of x. So that's 4 times x squared. So I recall that when I multiply a function by a number that's bigger than 1, we have a vertical stretch. In this case, a stretch by a factor of 4. So let's check on our graph. So I'm going to go to y equals. I'm going to put in 4x squared. 4x squared, and I see the stretch, much narrow, very tall and stretched. And then lastly, d of x will be 1/4 x squared. And I remember that when I multiply a function by a number that's in between 0 and 1, like 1/4, I get a compression. Notice how it's flattened out, very wide. That's called a compression. So we say this graph is compressed by a factor of 1/4. Okay, so just reviewing, we've got different ways to transform our graphs. Let's go back. We've got a vertical or horizontal translation. So we need to know when we look at a graph, is this graph shifted up or down or left and right from the parent graph? And then we could also have reflections over the x-axis and the y-axis. If we multiply the whole function by -1, we are reflected over the x-axis. But if we just multiply the x value by -1, then we are reflected over the y-axis. And then lastly, we have 2 ways to stretch or compress a graph. If we multiply a function, by a number that's bigger than 1, we stretch the graph, makes it taller and narrower. And if we multiply a function that's in between 0 and 1, then we have what's called a compression. Compress means flatten out or make smaller.